So welcome everyone. This is 9.3 using the quadratic formula to solve equations. So in this lesson, this is the final tool that I will give you that we're going to go over to solve quadratic equations. Okay, so in our toolbox, we have factoring, we have taking the square root, we have completing the square, and now we're going to have quadratic formula in our toolbox to solve quadratic equations. Okay, this one here is the most straightforward way to solve quadratic equation. Okay, because all we're gonna do, there's a formula to it, and all we're gonna do is figure out my A, B, and C value, which is super simple. And then all we're gonna do is just plug it in. Okay, and then simplify that. All right, so we must remember that ax squared plus bx plus c equals 0. Because we need our a, we need our b, and we need our c value. So notice here that our first step in these problems are going to be to set one side equal to 0 if it's not already. Okay, so we need to set one side equal to 0 in order for us to figure out our A, B, and C value. Okay, so that formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah. So once we get our A, B, and C value, all we're going to do is just plug it in. Okay. So the most difficult part about this is to plug it in and to simplify, which we'll practice in this lesson. Okay. So the best way to know this is just to memorize it. Okay. So before we get into our examples, I want to take some time to analyze this formula. Okay. So if we look at this formula, the quadratic formula, it will give us at most two solutions. Why is that? Why will this formula give us two, and I have it on the bottom, two solutions? Yeah. Because of the plus and minus. Yes. Because of that plus or minus, right? Negative b plus square root of b squared minus 4ac over 2a, and negative b minus square root of b squared minus 4ac over 2a. Correct? Yeah. So at most, we're going to have two solutions. Why do I say at most? The next part I want to analyze about this formula is what I have highlighted there, b squared minus 4ac. Why is b squared minus 4ac important? Because it's underneath the square root. Okay? So depending on that value, depending on the value of b squared minus 4ac, we can have 0 real solutions, 1 real solution, or 2 real solutions. Okay, it's either 0, 1, or 2. Okay, depending on the value of b squared minus 4ac. Now we're going to take some time to think about the value of b squared minus 4ac and why it's 0, or when b squared minus 4ac is this value, it's 0 real solutions. When it's another value, it's 1 real solution. And when it's another value, it's 2 real solutions. Okay? So let's take some time to think about what those values are. So here, I have the thing up, right? I have the quadratic formula up, and we're just talking about this value here. Okay, b squared minus 4ac. And a helpful hint, is that it is underneath that square root. Okay, so take a few minutes to think about what b squared minus 4ac has to be in order to have 0 real solutions, 1 real solution, or 2 real solutions. If b squared minus 4ac is a negative number, what is the square root of, let's pick a random negative number, negative 4. What is the square root of negative 4? You might think it's 2, but 2 times 2 is positive 4, not 2. Then you guys might think it's negative 2. Negative 2 times negative 2 is also positive 4, right? Yeah? So there's no number that I can plug in that'll get me a value of negative 4, correct? Yeah, so the square root of negative 4, it actually does not exist. Okay, in the future, we're going to talk about a number that it can make a value of it, not a real value, but a value, right? But in this case, if b squared minus 4ac is less than 0, there's 0 real solutions. There's 0 real answers. There's 0 real roots, right? Okay, because the square root of a negative number does not exist. If you put it on your calculator, it'll say like undefined or no solution or domain error, something like that, right? Which all means the same thing. It does not exist. Okay? When will I have 1 real solution? When b squared minus 4ac, when it equals 0. When b squared minus 4ac equals 0, that means that the number inside my square root, right? That number is 0, correct? So what is the square root of 0? 0, correct? Square root of 0 is 0. So negative b plus 0 and negative b minus 0, that's the same thing, correct? That's just negative b. So that's why we only have 1 solution, because that real solution will be negative b over 2a. Does that make sense? Questions on that idea? No? And when b squared minus 4ac is greater than 0, that means I have a real value, right? That means that the normal way of doing things, negative b plus that real value over 2a and negative b minus that real value over 2a. Those are my 2 solutions. That makes sense? So if we just get b squared minus 4ac, that value, right? And wherever that value falls, if it's less than 0, equal to 0, or greater than 0, we can say we're going to have 0, 1, 2, or 2 real solutions. Okay? So let's practice that. Oh, before we practice, b squared minus 4ac is also called the discriminant. So whenever you see the word discriminant, right, we're referring to b squared minus 4ac. Okay? So we're going to use the discriminant, which is b squared minus 4ac, to determine the number of real solutions for each quadratic equation. So we're not solving it. We're just telling you, right, the solution will be 0 real solutions, 1 real solution, or 2 real solutions. Okay? So here for number 3, I have this equation equals 0. So we have it in the form that we want, that we need. So I'm going to plug in b squared minus 4ac. Remember that my a value will be the number, the coefficient of my variable squared, which is 1. My b value is the coefficient of my variable, which is 4, and my C value is the coefficient of the, or not the coefficient, I'm sorry, is the constant, which is 1 as well. So if you look at this, B squared would be minus 4AC, right? My B value is 4, so 4 squared minus 4 times 1 times 1, right? A and C are both 1 in this case. So 4 squared is 16, minus 4 times 1 is 4, which we would get 12, right? A positive 12. Yeah. So since B squared minus 4AC, or my discriminant, is a positive number, we are going to have two real solutions. Okay. All right. So the next example, we have this. The first step is to check if it's equal to 0, which it is. So my A value here is 2, my B value here is negative 6, and my C value here is 15. Okay. B squared minus 4AC, just getting those values. B is negative 6 minus 4 times 2 times 15, right? Negative 6 squared is 36 minus, or not minus, 2 times 15 is 30 times negative 4 is negative 120, right? All we're doing is just simplifying, yeah? 36 minus 120 is negative 84. So since negative 84 is a negative number, we're going to have 0 real solutions. Okay? Because square root of negative plus or minus square root of negative 84 does not exist. Okay, you don't have to do that. You don't have to put that, write that out every single time, but I want to show you guys why. Okay? I want to show you guys why that works. And we're going to have two real solutions here because plus or minus square root of 12 is a real number. Okay? Because the plus, positive square root of 12 and a negative square root of 12, right? That'll give me two solutions. Okay? In the quadratic formula. Okay, the last one here. X squared plus 6x plus 9 equals 0. So it equals 0. So that's a check, right? So my A value here is 1. My B value here is 6. My C value here is 9. So B squared minus 4AC. So 4 times A times C, which you would have 6 squared minus 4 times 1 times 9. So 6 squared is 36. 4 times 1 is 4 times 9 is also 36. Minus, that's a 0. So if it equals 0, there's one real solution because square root of 0 equals 0. Okay. That makes sense, class? Yeah. I can put here plus or minus. Because plus or minus 0 equals 0. Okay. Make sense? Questions? What are they? So all we're doing here is we're just following this rule, right? The discriminant rule. And that is called your discriminant. Okay? All right. Now let's jump into some examples of solving this. Okay? So solve using the quadratic formula. So here, my first step again would be to check if it equals 0, which it does. So my A value is 1. My B value is -6. Please do not forget to take the sign with it. Okay? We need that sign with it. C value is -7. So remember the quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. Okay? So I'm going to rewrite it as x equals -b plus or minus square root b squared minus 4ac all over 2a. So just plopping in the numbers, -b is -6 plus or minus -6 squared minus 4 times 1 times -7 over 2 times 1, right? So here, we're going to have x equals negative times a negative is a positive. So I have +6 plus or minus the square root. -6 squared is 36. -4 times 1 is -4 times -7 is +28 all over 2 times 1, which is 2, right? So this, and then we just simplify, class. 6 plus or minus the square root of 36 plus 28, that is 64 all over 2. So we have 6 plus or minus square root of, or square root of 64 is 8 over 2. So in this case here, class, and let me put this on the bottom. In terms of this, right, 6 plus or minus 8 divided by 2, x is going to equal 6 plus 8 divided by 2 and 6 minus 8 divided by 2. That's what it means by plus or minus. Okay? So here in this case, x is going to equal 6 plus 8, which is 14, divided by 2 is 7. 6 minus 8, which is -2, divided by 2 is -1. Okay? Questions on this problem here? What are they? No? No questions? We're good, right? Now let's try this. Number 8, 2x squared equals 8x minus 7. So what's my first step? Make one side equal 0, right? So I'm going to subtract 8x and add 7. I'm going to try my hardest, or 8x, add 7. I'm going to try my hardest to make that x squared value positive. Okay, because that's a good habit to get into. So that's 2x squared minus 8x plus 7 equals 0, right? So we have that. Yeah. Now, since it equals 0, I can figure out my A, B, C value. So my A value is 2, my B value is negative 8, and my C value is positive 7. Okay? So x equals negative b plus or minus square root b squared minus 4 ac all over 2a, right? And I'm just going to plug in the values. Okay? I put all the letters down here just for reference. So x equals negative 8, negative 8, a times minus 4 times a, which is 2, times c, which is 7, all over 2 times 2. Right? I'm not worried about you guys knowing where your A, B, and C are, plugging it in. Okay? That doesn't worry me whatsoever. Okay? Even simplifying it, you guys might make mistakes here and there, maybe leave out a negative, maybe add it incorrectly, right? But I'm not that worried about it, right? So if we simplify this, it'll be negative times a negative, which is a positive, 8 plus or minus the square root of 64. Negative 4 times 2, that's negative 8 times 7, that's negative 56 all over 2 times 2, which is 4, right? So up to this point, it's going well. Pretty simple. So we have x equals 8 plus or minus the square root of 8 divided by 4. Okay? Pretty smooth up to here, correct? Yeah, we're good up to here. But now, we're going to have to simplify that. Okay? First thing in simplification is figure out if we can simplify that. When we're simplifying radicals, we need to remember the perfect squares. Okay? This list on the board right here. 1, 4, 9, 16, 25, 36, 49, 64, and so on and so forth. Right? Now 8, I can break that down into 4 times 2. Right? Now since I know the square root of 4 is 2, right? I'm going to rewrite square root of 8 as square root of 4 times square root of 2. Because that's one of the properties of radicals, right? We can break it down like that. correct? The square root of 4 is, so this square root of 4 becomes a 2, and then we're left with the square root of 2, because I can't do anything with that. Yeah? So square root of 8 simplifies to 2 square root of 2. Does that make sense? Yeah? So I can rewrite the answer as x equals 8 plus or minus 2 square root of 2 over 4. Right? Now I want to focus on this and simplify that. Okay? When we are simplifying this, we have to look at this number, look at this number, and look at this number. All three numbers at once. Okay? We have to look at all three numbers at once. Is there a GCF that I can divide by to make these three numbers smaller? A 2, a 4, and an 8. A 2, right? Your GCF is 2, correct? So what I'm going to do is divide everything by 2. So 8 divided by 2 is 4. Plus or minus 1. 2 divided by 2 is 1. Square root of 2. All over 4 divided by 2 is 2. This is the simplification of it, class. Okay? You guys might have the question of, no, wait, Mr. Lee. 2 and 4, I can still simplify 2 and 4, right? I can still simplify 2 and 4, right? You guys might be thinking that. Yes, you can, but not in this case. Because this number here cannot be divided by 2 anymore, right? The 1 cannot be divided by 2. So we just leave it as is. Okay? We can add the 1 like that, or you can even just get rid of it. Get rid of the 1. Okay? Because 1 times square root of 2, you don't really need the 1 there. Okay? You can leave it there if you want. Okay, like that, or you can take it away. All right? So I feel like the hardest part, the most difficult part of doing this is the simplification part. So let's practice that one more time and then we'll be done. Okay? So let's say for this example, we did the quadratic formula, right? We went through the steps. We got our A, B, and C. We put it into our quadratic formula, and this came out, right? How do I simplify this? Well, we do the same thing. 72. What does 72 break out to be? Remember thinking our perfect squares. 1, 4, 9, 16, 25, 36, 49, 64. 9 and 8, right? So I got two separate answers. I'm going to show you guys that we can use both answers. Okay? When I asked what times what is 72, one student said 36 times 2, right? Another student said 9 times 8. Both answers are correct. But when I simplify this, and when I hit a perfect square, I am going to circle it. Okay? I'm going to circle it, signifying that I'm done with that number. because I know the square root of 36 is 6, and I know the square root of 9 is 3. Although you can go some more and simplify it more down, right? Because 36 and 9 is not a perfect or is not a prime number, right? We can simplify it down, but we don't need to. Once I hit a perfect square, I'm going to leave it. Okay? But in the second example here, 8 can be broken down. We did it above, right? It becomes 4 times 2. 4 is also a perfect square. So I'm going to circle that. Okay? So in both simplifications, square root of 72 is equal to square root of 36 times square root of 2, or is also equal to square root of 9 times square root of 4 times square root of 2. Does that make sense? Yeah. I just got the numbers that we got here and here and put it in square roots, right? Here, here, and here, 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 and here. Okay? Using the properties of radicals, right? Questions on my simplification before we move on, before we simplify this even more. Everybody got that? Okay. So square root of 72 in our first simplification, square root of 36 is 6. Square root of 2 equals square root of 9 is 3 times square root of 4 is 2 times square root of 2, right? So 3 times 2 is 6 square root of 2. So the reason why I showed you guys both, yeah, is because I want to let you guys know either route you take, you're going to come back to the same answer. Okay? Doesn't matter what route you take as long as you break it down correctly. Okay? All right, so square root of 72 is 6 square root of 2. So this part here becomes 30 plus or minus 6 square root of 2 over 12. Right? Now we have to look at this number, and this number. What is my GCF between 6, 12, and 30? You can divide it by 2 first. You could get a GF. No. A CF, right? A common factor. So if you divide it by 2, let's say you think it's 2, right? The greatest common factor is 2. Divide that by 2, divide that by 2, divide that by 2. Then we get 15 plus or minus 3 square root of 2 over 6. Now again, look at this number, look at this number, and look at this number. Is there a GCF? 3. Yeah. So if we divide everything by 3, we're going to get, what's that, 5 plus or minus 1 square root of 2. So I don't need that 1 anymore. Over 2. That is the simplification. Okay? That makes sense? Yeah. Or you could have just, from the first step, the 30, the 6, and the 12, you could have divided the whole thing by 6.